The overall goal of this procedure is to observe the effect of various growth parameters on the structural and electrical quality of nitride semiconductors and their eventual impact on the performance of electronic devices.
This method can help answer key questions in the fields of materials science and electrical engineering, such as the impact of materials defects on the speed and power of wide bandgap transistors. The main advantage of this technique is that it can produce semiconductor materials with very abrupt interfaces and low impurity levels, which are very important for high-performance devices such as transistors. Visual demonstration of this method is critical, as distinguishing between too much and not enough gallium coverage with reed is qualitative and difficult to describe.
First, ensure that the cryo panels are cooled and that the growth chamber is at base pressure. Ramp up the effusion cells to their beam flux measurement temperatures at the proper rates and wait 1 hour for the cells to stabilize. For each cell, open the shutter for 30 seconds to collect a beam flux ion gauge measurement, then close the shutter for 1 minute. Perform this process 3 times. Average the last 2 measurements for each cell. Use previous calibrations to set the cell temperatures to achieve the desired fluxes. Close the load lock isolation gate valve and vent the load lock chamber with nitrogen gas. Load the epitaxy-ready N-polar gallium nitride substrate on the holder and place the sample cassette in the load lock. Close the load lock and shut off the nitrogen gas. Turn on the load lock roughing pump. Open the roughing pump valve and the manifold valve.